Hello, welcome back to my channel. This is Lekana. Today I am here with a new topic, importing modules in Python. Firstly, what is importing modules? In Python, importing modules is a process of including external code libraries or modules into your program to access their functions, classes and variables. By looking at the definition, you come to know in Python, importing modules are the process of including modules. Modules are nothing but these are the files which contains Python definitions and statements which defines functions, classes, variables, and also they make the code logically operated into your program to access their functions, classes and variables to your currently working program. You can import modules using the import statement followed by the module name. Next, we have standard libraries. Standard libraries are nothing but these are the collection of modules. We have many such modules, but in this video I'm going to explain only this math module, OS module, Matplotlib module, NumPy module and SymPy module. Now, math module. The math module in Python is a built-in module that provides a wide range of mathematical functions and constants. It is a part of Python standard library and doesn't require any external installation to use it. Most commonly used functions and constants. The mathematical constants are like math.pi, math.e. Math.pi constant retains the value of pi 3.14 and so on. And the mathematical pi is represented by the Roman number pi. The math.e constant returns the Euler's number, which is 2.7182. You can check this while coding this. I'll show you. You can see here. First we need to write the math module. Import math, enter, print math.pi. If you run the program, you'll get this output 3.14.5926 and so on. If you re-enter this Euler's value, even you get even this value. See, you can see 2.7180 and so on. Basic mathematical functions. We have math.sqrt, which is related to the squaring of numbers, math.power, which are related to powering that numbers, math.exp, related to exponential, math.log, these are used for logging operations. You can see this, I'll code like import math, enter, print math.sqrt. You can give any number. I'm giving like 6. Awesome. I forgot to keep the bracket. You'll get like 2.44 because 6 is not a perfect number, right? If you give 4, you'll get the correct one, 2.0. As the same way, you can code for math.power also. Now you can code this pow, import math, enter, print math.pow, and you can give 2, 2. If you run, you'll get like output is 4. Understood how to use this importing modules? Now This gives the exponential value of that number. If you give exponential of 2, you'll get like 7.3890. And if you give here logging operators, log of 2 is 0.69, you'll get everything by using the small importing modules. OS module. OS module in Python is a built-in module that provides a way to interact with the operating system. It allows you to perform various operations related to the file system, directories, and process management. This module comes pre-installed with Python and does not require any external installation. Some common functionalities and function provided by the OS module. First is file and directory operation. OS.getCurrent working directory, which returns the current working directory. OS.remove removes a file at a specific path. OS.change directory path changes the current working directory to the specified path. These are the file and directory operations. Next is file path operations. OS.path.join path into paths, which joins one or more path components intelligently. Next is OS.path.exist. This checks if the specified path exists. OS.path.is file path checks if the specified path is a regular file. OS.path.is directory path checks if the specified path is a directory. We have Matplotlib module. Matplotlib is a widely used Python library for creating 2D plots and visualization. It provides a powerful and flexible plotting toolkit that allows you to create a wide range of plots, charts, and graphs to visualize data. To use Matplotlib, you need to import it in Python script or a Jupyter notebook. The syntax of this module is import matplotlib.pyplot as plt. Types of plots. Matplotlib supports various types of plots including lines plots, scatter plots, bar plots, histograms, pie charts, box plots, heat maps, 3D plots, and more. You can see one by one. Here line plots, you can see it will show the output like this. Line plot is a graphical representation of data points connected by straight lines. And the scatter plots, you can see that image. Scatter plots are used to explore relationships between two continuous variables. Histogram plots. Histogram plot shows the distribution of a dataset. They are used to explore the shape of continuous data. You can see that image of this histogram plots. Next, we have bar plots. Plots are used to compare difference in the datasets. They are used to compare discrete data. You can see the related image. Pie plots. Pie plots shows the distribution of categorical data as a circle. They are used to show proportions of parts to the whole. We have seen these pie plots. And box plots. Box plots is a graphical way to show the spread and distribution of data in a dataset. It looks like a rectangular box with lines extended from it, etc. And next is NumPy. NumPy is a powerful Python library used for numerical computing. It stands for Numerical Python and provides support for large multidimensional arrays and matrices, along with an extensive collection of high-level mathematical functions to operate on these arrays efficiently. NumPy is an essential tool in the data science and scientific computing communities. Next we have SymPy. SymPy is a Python library for symbolic mathematics. Unlike NumPy, which is focused on numerical computation with arrays, SymPy deals with symbolic mathematics, where mathematical expressions and equations are represented as symbolic objects. It allows you to perform algebraic manipulations, solve equations symbolically, differentiate and integrate expressions, and perform various other symbolic computations. Here are some key features of SymPy. Symbolic expression. SymPy allows you to define symbolic variables and perform all algebraic operations with them. These variables can represent real numbers, complex numbers, or even abstract entities like functions. Algebraic manipulations. SymPy can simplify expressions, expands and factor polynomials, perform algebraic manipulations like substitution, simplification, and handle rational functions. Calculus. SymPy supports symbolic differentiation and integration, making it useful for solving problems in calculus, including finding derivatives, integrals, limits, and solving differential equations. Solving equations. SymPy can solve algebraic equations symbolically. It can define solutions to linear and non-linear equations, systems of equations, and even transcendental equations. Next, it will also solve these matrices. SymPy provides support for symbolic matrix operations, including matrix multiplications, inversion and eigenvalue computation, series and limits. SymPy can compute Taylor and Lorentz series expressions and find limits of expressions as variable approach specific values. Thank you for watching my video.